Okay, thank you. In fact, it goes the other way too, because you have a lot of plugins to the AI system. So for example, GPT-3 is now using Mathematica, which improves its computational ability quite significantly. And I think you'll see a lot of these hybrids both ways. Okay, so this is called Artificial Intelligence and Market Design. And I decided that my strategy would be I'd listen to all the comments about AI that are made and then disagree with them all. But AI has hardly been mentioned, just a few times at the sessions. I had to come up with something with a little more content than that. Before I get to it, I do want to say I'd like to emphasize the issues and ideas that I'm going to discuss are my thoughts only and do not in any way reflect the views of my employer. So I've made the offering there. Okay, so artificial intelligence. Well, in the last 10 years, we've seen these incredible breakthrough applications, starting with computer vision by the Jeff Hinton and his group in Toronto, and it's really been quite remarkable how quickly that evolved into these more, what should I say, creative models that have been developed. So we've seen that breakthrough applications in chess and Go, protein folding, which is said to be a 50-year advance on what we could do prior to that. Weather forecasting has improved dramatically, and of course, our friends, the chatbots, who have entertained 100 million people in the last few weeks. On mechanism design, I'd say it's older. In the last 20 years, the mechanism design has moved from theory to practice, as we saw today. That's the bottom line message I got out of the discussions. And we've heard compelling examples there too in a number of things: environment, education, housing, spectrum, and many, many others. So it's a great accomplishment, but our punishment is now we have to deal with the real world. Before, there were just nice, beautiful little economic models. But I think a theme that's run through all of these presentations have been, well, that's the first step, but to really make it useful, you've got to add flexibility to it. You've got to make it work in environments where it doesn't work already. And this was a great example of the approximations you had to make that ended up being pretty good approximations, but they were not part of the sort of textbook approach. So I said I wanted to talk primarily about AI, almost, well, very little bit about mechanism design, since I'm supposed to try to combine the two. And I'm going to discuss military applications. Now, military applications are very, very important. There's a great deal of interest in this around the globe, and I'm including not only the conventional warfare, but also terrorism, riots, gangs, all sorts of conflict resolution issues. And the question is, do we have anything to say about this? I would hope so, since it is such a large section of the economy. The things that we've talked about should apply in that context, both on the AI, as you'll see in a few minutes, and on the mechanism design. And we're seeing that, of course, in the Ukraine with the drone wars. I mean, it's amazing. Those were not conceived of as a tool that was ready for deployment, but it has been, of course, used quite successfully, and we're going to see more of that in the future, I'm afraid, than we would like. But we will simply have to learn to live with it. So, what is the role of game theory and mechanism design in the military? Well, I want to start out with a little historical look at that. There's a paper in the JEP called The Gift of Mars. And the premise there is that wartime conflict has been a huge driver for innovation. In fact, the author argues that that is why Western Europe became advanced earlier than other areas, because they were in this continual warfare that put on a continual push on making the on innovation, essentially. But if we look at more recent history, look at RAND. Many of you have been involved with RAND in one way or another, reading working papers, journals, talking to people, reading things that were developed there. That was established in 1945, just at the very end of World War II, because the people had realized how much technology contributed to the success in World War II, radar being one common example, but also game theory. And here's what they said. They said at the very end of World War II, RAND's mission was connecting military planning with research and development decisions. So the primary goal, they'd had so much success working with the technologists during the war that they want to make sure that that would continue in the future as a deterrent to future wars, which more or less, it did to some extent. And it was only much later that computing, economics, policy, and so on became part of RAND's portfolio. It started out as a way to coordinate academic research and military needs. So if conflict can be analyzed using game theory, which is their view, and I think many of us would hold exactly the same view, then what is the analog of mechanism design in that context? Because remember, you're applying game theory to a situation. And I think if you look at things like arbitration and treaties and diplomacy and negotiations and contracts, all of these ways you coordinate activity, those are a kind of mechanism design, in my view. And they're particularly appropriate in this artificial intelligence context. Why? Because one of the things that we know you can do with these generative models is that you can manage large documents. You can look things up, you can create the documents, you can make them longer, you can make them shorter. You can do all sorts of manipulation that's going to help in dealing with coming to an agreement or coming to a situation where you can use the document to govern future activity. And the hope is that the generation of treaties and the generation of the arbitration and diplomacy context, you can end up with something that is helpful in terms of preserving the peace. So that's the story of World War II. What happened subsequently? Well, DARPA, which was the Defense Advanced Research Projects Agency, has continued to work with the research community in a variety of ways. Most importantly is they deployed the internet. So why was the internet deployed? There's lots of myths floating around. What happened was Japan was making a lot of advances in supercomputing. The US decided to build supercomputing centers that academics and other researchers could use. And they couldn't build one at every university, so they built, I think, about a dozen of them, and then put them all on a network, the internet, and that was the start. The backbone of the internet was basically ARPANET, or DARPANET, as it was called a little later. And there were 3 search engines that came out of DARPA. There was once they did the digital communications problem, once they'd solved that using the internet, then there was the issue of where do you get the content that goes onto that network. And that's what prompted DARPA and the NSF to create the Digital Library Program, which was created, I think, in 1995 or 1994. And that innovation, that funding is what led to 3 search engines, one, namely Google, Inktomi, Google from Stanford, Inktomi from Berkeley, and Lycos, which was Carnegie Mellon. Actually, Lycos was already going by the time the digital library came around as a commercial enterprise, but the people involved in Lycos at CMU also worked with the researchers who were funded by the digital library programs. So what's the role of AI in international conflicts. That was a question I set for myself, since I was supposed to try to relate the two concepts. Clausewitz said, famous quote, "War is a mere continuation of policy with other means." Okay. Now, my response is that may be true, but wars end sooner or later while policy goes on forever. So one of the things is that the innovations that come from creating the mechanism design problems that are appropriate and useful for the military also spill over to the civilian sector, and I think stimulate research in a way that has been very, very fruitful in the past. And perhaps the AIs can play a positive role in making the documents I referred to before, easier to write, easier to translate, easier to understand, and easier to verify compliance. And Susan mentioned the point earlier that as you have new innovations, you can observe the functioning of the in the mechanism design problems and see whether people are consistent with the policies that they're supposed to be following. And of course, that's done a little differently in the private sector and the military sector, but the goal is really the same. Now, document management may sound pretty mundane, but when you think about it, the world really runs on exchange of documents. And those are contracts in the private sector, and they're treaties in the international diplomacy sector. So all sorts of things. And there has been, I think, some quite interesting analysis that's emerged in the last really few years, just 4 or 5 years, about the role of technology, especially AI technology, in the military industries. Let me recommend a new book called Four Battlegrounds: Power in the Age of Artificial Intelligence. It's a little bit of a glitzy title, but it's actually a very good book, and I think you would find it interesting if you want to pursue some of these topics. Now, one of the themes that shows up in that book is emphasizing the fact that AIs are different from humans in very important ways. And so when conflict arises, there's going to be not like meeting like, but like meeting unlike. So you've got a more complex environment. First, if you look at AIs, they're hyper-rational. So that means that game theory can apply a better framework to understanding strategic AI behavior than of human behavior, because the AI behavior is generally much more predictable than the human behavior. And I'll give some examples in a few minutes. And in fact, I wrote about this idea way back in 1994, wrote a paper on mechanism design for computerized agents. And what it said is game theory has been justly criticized for its hyper-rational view of human behavior. And I think all of us who've worked with real data that's supposedly modeling recipients of grants and housing and all this other stuff that we've heard about over the last 2 days, it's clear that you can't really model the humans as hyper-rational, but hyper-rationality may be appropriate for choices made by software agents, since they presumably have a much better computational power than human beings. Although I guess they can ask, what was you wanting, 4 plus 4 or 2 plus 2? And sometimes needed a little work on getting that to function correctly, but it's working much better now. So second point about AIs, how they're different than humans, they don't make mistakes. Now, they can be mistaken, they can be fed information that's not accurate, that's certainly possible, but they don't make mistakes by pushing the wrong button because they're too tired to function, or they haven't had something to eat, or all these sort of little things that can distort behavior. And the computers are generally, the AIs are generally going to do it with more accuracy. So more important point is that they can train themselves. And this is how DeepMind was able to conquer Go and chess, for example, and the application of adversarial AI, where you're pitting AIs against each other, is a really effective way of doing simulation and strategic analysis. As Demis Hassabis has said, if you program AI to play chess in the morning, by lunch it can beat most players, and by evening it's stronger than the world champions. And I don't think he's really exaggerating. I think that's pretty much a day's worth of this learning can give you, adversarial AI can give you really truly remarkable results. And fourth, this is a very important difference between the humans and the AIs. The AIs don't care if they survive or not, whereas humans care quite a bit about this. And if you look at the difference, you know, one human doesn't exactly replace another, but one AI can exactly replace another AI. So what is the cost that should be taken into account with the calculation of something that risks the existence of the AI? Well, it's just the cost of building a new AI. And that can be really quite small. Well, that gives the AI a huge advantage in the bargaining, in almost any kind of bargaining. If the bargain is we're bargaining over something and my adversary says, I'm going to blow up myself and you. Well, we're at a Nash equilibrium, right? It's just not some game perfect. And the same thing happens, you think about the AI choices are all done in a very, very different manner than the human choices. A nice example from the book I mentioned earlier was they used flight simulators and were pitting an AI program to a human program, and the AI won all of them. I mean, won all of the battles. So why was that? Because the maneuver it was using was forbidden to be used by the human pilot because it was too dangerous. And that was not a concern for choosing what strategy to follow for the AI. So yes, I call that artificial bravery. That's supposed to be funny, but maybe not. All right. So, but they're different in lots of ways. That was just one example. Another example where they play chess differently. They play Go differently. They fly the fighter jets differently. And experts who study AlphaGo's playing style described it as alien. That is something that no human would play around a Go in that manner, or from an alternative dimension, which is another term used by the Go experts. And the chess people said the same way. I've never seen a move like that conducted in chess. So it's like meeting an alien race that does things differently, like playing chess, playing Go, playing poker. All of these things could be different. And of course, fighting wars and engage in this kind of conflict. That's why I said you've got different approaches because of these distinctions in how AIs compare to humans. Not all of these differences, I should say, between the humans and the AIs operate to the advantage of the AIs. Just because we're different doesn't make it clear who's going to be in the winner's circle in our conflict. The performance of AIs tends to be very brittle. Okay, so what do I mean by brittle? Well, take an AI that's trained on a Go board. The standard measure is 19 by 19 cells, and you give it that. If you give it the 19 by 19 cells, what you'll see is a machine do very, very well. But if you moved it to 13 by 13 or a trainer board, they would just be terrible, easy to beat by a human being. And there was a great example of DARPA engineers who designed an algorithm that detected soldiers in dark and adverse conditions and so on. And he got 8 Marines and said, I'll give a $100 prize to whoever gets to that, pushes the button over there in the traffic circle. So what happened was not a single Marine was detected. Why was that? Well, they disguised themselves. One of them put a cardboard box over his head. The other one put branches of tree branches around his body, so it looked like a tree that was moving. 2 of them somersaulted for 300 meters to get to the prize. The machine didn't recognize them. In fact, I think this is an explanation of why Congress is so concerned about TikTok. I think they're worried that some North Korean soldiers could learn how to dance by seeing TikTok, and then they could just waltz right across the DMZ. You heard it here first. So. All right. Let's see. I'll say one last word about terrorism. So we now know that planes, cars, tracks, tractors, all these vehicles are in fact potentially lethal weapons. They've been used in that way in the past. And they had the unfortunate characteristic that the pilot of the car, or the tractor, or whatever, basically was committing suicide in many of these cases, and that deterred a lot of these terrorist acts. But if you have autonomous vehicles, then that problem goes away. It's the same thing that I mentioned earlier. So that's going to mean that you really have to design these autonomous vehicles of all sorts in a way that's highly secure to prevent them from being hijacked and used for other nefarious purposes. So earlier, I mentioned the famous quote from Clausewitz that war is mere continuation of policy through other means, but policy is also a way to avoid war, these treaties. That's their goal, is to do that. So they can be improved for better rules for detection, translation, deployment, avoidance. And so maybe these generative AIs could be useful in both war and in peace. So that's my talk.